Welcome everyone to our Duke Sanford School of Public Policy Cyber Policy Lecture Series. It is my great pleasure today to welcome my friend and former colleague from Intel, Riccardo Masucci, to give a talk on the global semiconductor supply chain. Riccardo is Director of Security and Technology Policy at Intel and coordinates Intel's policy work on the EU CHIPS Act. He serves as advisor on global public privacy policy to the Intel Government Affairs team. He chairs industry working groups focusing on security and privacy policy at Digital Europe and the Cybersecurity Coalition. He's also a technology policy visiting scholar at Duke University. Prior to Intel, Riccardo served as policy advisor to members of the Justice and Home Affairs Committee in the European Parliament. He holds a master's degree in international diplomacy and economics. And I'm very excited that he's agreed to join us today. Riccardo, thank you so much. I do want to do a small disclosure that Intel does provide research funding for our cyber policy program, but not in any way connected with this talk. The current research funding has been looking at the carbon footprint of the technology supply chain, so not associated with these topics. Riccardo is going to deliver prepared remarks, and then we will take questions afterwards. You can put questions in the chat, and then I will read the questions, or you can, when we get to the Q&A portion, raise your hand in the tool, and then I'll call on folks to unmute and to ask the question. So Riccardo, with that, take it away.
Thanks a lot, David, and good morning, everyone. I'm delighted to be here with you today. Thanks also for the opportunity to share with you my views on semiconductor policy. I know it's a busy period for students, and so I'm very glad to be here with you today. I'm part of the government affairs team that is supporting Intel investment strategy IDM 2.0, announced last February by our CEO, Pat Gelsinger. The government affairs team has driven the work with governments in the US and in Europe that led in the last months to two major announcements for planned investments for 2 chip factories in Ohio and a new mega fab in Germany, as well as a new R&D hub in France and additional R&D, manufacturing, and foundry services in Ireland, Italy, Poland, and Spain. These are major developments for the semiconductor sector, and so Professor Hoffman and I thought it might be interesting to share with you some of the knowledge and the insights that I acquired with this working experience. Today, I would like to describe how some trends and unexpected events made the semiconductor sector more vulnerable over the past years and led to the current chip crunch. I would like also to sketch what policymakers around the world are doing to address supply chain vulnerabilities. And I would like also to conclude by giving an overview of public policy tools available, including incentives for large manufacturing facilities. Considering the critical role of semiconductors in driving innovation and economic growth, it is not an option today for governments to wait and see, and it's urgent to put in place ambitious policies to foster private and public investments that will ensure long-term prosperity. Let me start by somehow setting the scene and trying to align on few concepts on the semiconductor supply chain. We use the word semiconductors to commonly refer to integrated circuits or microchips. So a microchip is a set of electronic circuits on a small flat piece of semiconductor material that is usually silicon. There are different types of chips. Just to mention the most important ones, we have logic chips, which are commonly central processing units or graphic processing units or application-specific integrated circuits. All these can perform very sophisticated computing tasks for technologies like artificial intelligence, autonomous driving, etc. Memory chips are the second type of chips. You might be familiar, for instance, with the DRAM or NAND. And then another type of chips that is very relevant to the discussion today is analog chips, which are often used for specific functions in consumer electronics, automotive, and other sectors. With this slide, I think it's really important to focus on the three fundamental steps of production. You can see it on the left side or of the slide. We have three fundamental phases. One is design of chips. Then we have the front-end manufacturing, so the fabrication of wafers with all the different steps of this fabrication. And finally, there is back-end manufacturing, which usually refers to assembly, test, or packaging of products. So once the semiconductor products are assembled, are designed, manufactured, and assembled, then they can be integrated in end products by original equipment manufacturers or electronic manufacturing services like Foxconn in Taiwan, and maybe some of you know. An important point to add here is the fact that R&D activities happen across the entire supply chain. So it's not just semiconductor manufacturers that are making R&D pre-production and throughout the manufacturing process, but it's also very important that suppliers of software design or suppliers of equipment, tools, materials that push the limit of innovation through additional R&D activities. It is really important in this in preliminary phase of our discussion today also to distinguish between the two main business models in the semiconductor sector, namely integrated device manufacturers and fabless companies. So the integrated device manufacturers carry out all the three phases, so design, fabrication, assembly, internally, while fabless companies, and this is the case of Qualcomm, Broadcom, NVIDIA, AMD, they actually design the chips, but then they outsource the fabrication to foundry businesses like TSMC or Global Foundries. And then they also outsource the assembly and test phase to outsource semiconductor assembly and test companies like ASE Group, Amkor, JCET in China. Samsung is an example of an integrated device manufacturer that has also a foundry business that offers also foundry services. And as of last year, also Intel does the same. Let's start then with looking at the current supply chain shortage. And I think that in the last couple of years, delayed deliveries of consumer electronics, cars, and other items have been a common experience. However, there are more reasons beyond the pandemics and the disruptions caused by the global health crisis for the current chip shortage. The current chip shortage is a confluence of long-term vulnerabilities and unexpected events. And I made here on the slide a list. At the beginning of the pandemics, cars makers cut their chip orders as vehicle sales started plummeting. But when the demand recovered in the second half of 2020 faster than anticipated, the semiconductor industry had already shifted production lines to meet demand and consumption of consumer devices or cloud services, and so demand and for other applications. This demand was driven mainly by teleworking, distance learning, and all the entertainment that we used during the lockdown period. This situation during the pandemics made even more apparent the imbalance in the global supply chain, where Asia, and we will see this also in more details later, Asia accounts for about 80% of the global production, while the manufacturing capacity in Europe and in the United States steadily declined over the past 30 years, making Western economies dependent on Asia. The fabless model that I referred earlier in the presentation, together with very favorable semiconductor policies in Asian countries over the past decades, accelerated the production in Asia and the concentration of production in Asian countries. We must keep in mind also, among the vulnerabilities and the factors leading to the current chip shortage, also natural disasters. A severe blizzard in Texas in February 2021 resulted in manufacturing downtime for several companies, including Samsung and NXP. And last but not least, I also included in this list geopolitics, because some geopolitical events can affect negatively the global supply chain. We saw this clearly, for instance, in the past year with the trade tensions between the United States and China, which led to export control measures and bans of technology products. If we want to look in more detail at some of the vulnerabilities that I just mentioned, we can probably start considering the surge in demand of semiconductor across all industrial sectors. In Europe, for instance, this is a chart that comes from a study carried out by Kearney, a strategic management firm. This chart shows how technologies like AI, autonomous driving, 5G, cloud, IoT will drive higher chip consumption in the next decade in Europe. And leading edge chips, according to the study carried out by Kearney, leading edge chips that are usually those 10 nanometers chips or below, well, these are the key chips enabling technologies like AI, 5G, autonomous driving. These leading edge chips, the most innovative chips, will have a yearly consumption growth of about 15% between now and 2030, while mature nodes, which are those above 10 nanometers, will steadily, the consumption of these nodes, of these chips, will steadily grow about 3% every year. We can think of similar trends for the US and China, and it is clear now that the need for semiconductors is here to stay if governments and industry do not take immediate remedial actions. If we look at the global production capacity by location, this gives us an immediate picture of some of the current supply chain vulnerabilities. While the two charts on the slides might not be easy to read, I would like to ask you to try to focus on the two lines at the bottom of the two charts, those in green and those in purple, that represent the declining manufacturing trends both in the US and in Europe. In the 90s, the United States and Europe, their capacity accounted for about 37 and 44%. So US 37%, Europe 44% of the global production capacity. In the year 2000s, they were about 19 and 24%, while today US and Europe account respectively for about 12, 10% depending on the estimations, and 9, 8% depending on the estimations. You will notice also on these graphs that the manufacturing capacity of countries like China, Taiwan, South Korea has become more and more significant over time. This confirms how unbalanced the production is across the regions of the world today. And this imbalance is even more apparent when we look at leading edge capacity by location. The increasing role of Asia in manufacturing chip is now extremely prominent, and the majority actually of leading edge chips, again, those that are 10 nanometers and below, those that are really powering AI, 5G, autonomous driving, IoT, cloud, those chips are mainly produced in Asia. This chart doesn't take into account the recent announcements made by Intel of 2 new mega fabs, as I said, one in Ohio, US, and one in Germany. These 2 new mega fabs might help mitigating the declining trends both in Europe and in the US. But it is clear, again, from the studies of experts and from the views of experts, that more investments in manufacturing facilities are needed to rebalance the global supply chain, considering that Asia today concentrates over 75% of the global fabrication capacity. The high concentration of semiconductor capacity and capabilities in just few countries, in just few regions of the world, clearly represents a vulnerability. If you look at the top 3 players and their manufacturing locations, it is apparent how leading edge fab capacity relies on just few locations. A high concentration of manufacturing capacity increases the risks of single point of failure for the entire supply chain if anything happens in one of these facilities. That is why adding 2 new locations in 2 different countries, as Intel is planning to do, it is a very important development, not just for one company, but for the entire supply chain. In this context, it is also useful to show how in the past 20 years, the increasing costs and complexity of manufacturing leading edge nodes drove to a clear consolidation of leading edge manufacturing. In fact, today, there are only 3 companies that can afford producing at 10 nanometers and below. These are TSMC, Samsung, and Intel, who can really afford the technology and the expertise to manufacture leading edge chips. The capital investment to stay ahead of the innovation curve has become really hard to sustain for the majority of players. Look at the early 2000s when there were over 20 players. Now today there are only three players that are only 3 companies that are able to produce 10 nanometers chips and below. It is interesting also how the costs of establishing a new manufacturing site have grown exponentially over the past 2 decades. The graph shows how in the early 2000s, a leading edge fab costed about 1 billion, and now costs between 10 and 15 billion, depending on the technology. Paul Otellini, former Intel CEO, once said, our business model is one of very high risk. We dig a very big hole in the ground, spend $3 billion to build a factory in it, which takes 3 years, to produce technology we haven't invented yet, to run products we haven't designed yet, and for markets which don't exist. So this quote really well reflects the risk and unpredictability attached to the semiconductor business today and the hurdles that the different semiconductor players need to overcome. I made reference already to tech complexity and need for scale. These are other two reasons that really led to specialization across industry. This chart by BCG, another consulting firm, highlights the layer specialization throughout the three production phases that we mentioned earlier in the presentation. So design, front end, and back end manufacturing. And this specialization and concentration in few countries shows clearly how countries have different strengths in the different segments of the supply chain. We mentioned already some names, but let me go through the major players today. US companies, for instance, are very strong in electronic design automation. Some important companies are Cadence, Synopsys. Also, Mentor is a US company that was recently acquired by the European Siemens. The US are also strong in fab equipment. There are important companies like Applied Materials or Lam Research. There are also many new US players that entered the chip design arena. This is the case of Alphabet, Amazon, Tesla, Meta. I already mentioned some of the fabless companies in the US, like Qualcomm, Broadcom, NVIDIA, AMD. And there are also several integrated device manufacturers like Intel, like Texas Instrument, Micron. If we look at Europe, companies specialized in some industrial sectors like automotive. So we find very strong manufacturers of automotive integrated circuits. This is the case of prominent IDMs like Bosch, Infineon, NXP, STMicro. ASML, for instance, is a Dutch company that produces fab equipment, and they are the top extreme ultraviolet lithography supplier for the world major manufacturers. Europe is also very strong in supplying fab equipment. This is the case of Zeiss in Germany, or chemical suppliers like BASF, or wafer producers like Siltronic in Austria. Europe is also very strong in R&D with excellent centers like IMEC in Belgium, Fraunhofer in Germany, or Cealetti in France. If we look at China, if we start looking at Asia, China's presence in the semiconductor sector is still limited, but it gained more market share in chip design thanks to HiSilicon, which is a subsidiary of Huawei. China is growing also in assembly with companies like JCET. SMIC in China offers foundry services. They are the fifth player worldwide. And in general, it is no secret that China is investing massively in the semiconductor sector and offers very favorable incentives to semiconductor companies. South Korea is another key player in the semiconductor value chain. South Korea is prominent for companies, integrated device manufacturers like SK Hynix and Samsung, who are extremely prominent in the memory market. Samsung is also a founder business, as I mentioned earlier. A very interesting player in the semiconductor market worldwide is Taiwan, which has the highest fabrication capacity thanks to TSMC activities. TSMC, as I said, offers foundry services, but Taiwan has also very important players in the fabless world. with companies like Mediatek and Novatech. And there are also important backend companies like ASE Group. Taiwan is a very interesting example because it shows the importance of co-locating design, front-end, and back-end manufacturing, because these various segments boost each other, and they overall boost the semiconductor ecosystem. And finally, Japan represents another important country in the semiconductor world, thanks to silicon wafer production. Shinetsu and Sumco are prominent companies here, but there are also very important chemical suppliers like Sumitomo and Mitsui. And there are also some important integrated devices manufacturers like Renesas and Kioxia. Keeping in mind all the strengths that I just listed in the different countries, there is no doubt that the role of governments in these countries, in these regions of the world, is going to be key for the semiconductor sector going forward. European and American policymakers took initiatives in the last couple of years to boost innovation, to increase the supply chain security, to actually mitigate risks of future chip shortages. But the Asian countries are not watching. They have already put in place ambitious goals and strategies consistently with what they have done over the past decades to support the semiconductor industry. As you can see in the slide, all the countries, US, EU, China, South Korea, Taiwan, Japan, they all allocated conspicuous public resources, or they are planning to mobilize important public resources to execute these strategies. What is the common denominator of all these strategies? What all these strategies have in common? Firstly, they are driven by the acknowledgement that semiconductors will continue playing a critical role in ensuring long-term competitiveness in the global digital economy, because they are the key ingredients of connectivity, computing, and they have very innovative applications in healthcare, transportation, energy, and many other sectors. Secondly, countries want to be resilient to future chip shortages, and they consider semiconductor design and manufacturing as a matter of cybersecurity, as a matter of national security, as a matter of security of the overall supply chain. This leads to the third factor, which is the tech sovereignty approach. Tech sovereignty is meant to increase countries' control over technology production, and in a way that they can also reduce dependencies from other countries. This is described as self-reliance, for instance, in China. The European Union is trying to achieve an open technology sovereignty, an open strategic autonomy. But all these different approaches to tech sovereignty are motivated by similar geopolitical reasons. In the previous slides, I showed how increasing costs to innovate, technology complexity, and the need to scale, they actually led to increased concentration in few countries and regions, and hyper-specialization of companies in specific segments of the value chain. So it is crystal clear that there is no one single country or region in the world that can reasonably think in the near future to become fully independent or autonomous in their semiconductor supply chain. And this is why it is of utmost importance that the semiconductor supply chain remains global, to really leverage the strengths of different countries and regions across the world. And therefore it is really important that international cooperation of like-minded countries takes place to advance semiconductor strategies and the overall technology goals of the different countries around the world. If we look more closely at the European Union and the United States, I would like to start with the EU Chips Act, which is a package of measures, a package of initiatives that was published by the European Commission last February, and which comprises several pillars. The first one is has a focus on innovation through investments in research and development. The second pillar is about increasing supply chain security by fostering public support to large investments in first-of-a-kind innovative manufacturing facilities. The third pillar is focusing on creating a mechanism for coordinated crisis response in case of future shortages. The European Semiconductor Board, comprising representatives from the European Union and member states, will play an important role in defining some of the details of the strategy, but also some of the details of the requirements that the EU will ask to the semiconductor sector. The budget that the EU Chips Act aims to mobilize is roughly 43 billion euros, which approximately corresponds to the 15 billion US dollars that the US Chips Act would like to mobilize. But it is fair to say that the financial breakdown of the EU Chips Act is still fuzzy, especially because the lion's share of this amount of money, 43 billion euros, will actually come from private investments and from member states. And except for Intel, that has announced investments for 33 billion euros in Europe, there are no there have been no other announcements so far. The European Semiconductor Board, as I said, will have a critical role in helping defining the strategy. The US Chips Act, since we mentioned the US Chips Act on a couple of occasions, the US Chips Act was enacted by Congress in the NDAA 2021. Congress recognized the critical role of the semiconductor industry, and both Senate and both Senate and the House passed competitiveness legislation, USICA in the Senate and Competes Act in the House. They both include a reference to 52 billion US dollars in semiconductor investments. However, joint legislation is needed to move forward with this funding and finally get approval for this funding. US legislators are also looking at the FABS Act, so they are also considering other measures that would establish tax credits for semiconductor investments, and they would also further increase expenditure for design and manufacturing to really help strengthen the entire semiconductor ecosystem and in order to attract more private investments. It is clear from the description that I made of the EU Chips Act and the US Chips Act that policymakers on both sides of the Atlantic acknowledged already the significant security risk inherent in geographically unbalanced supply chains. And both the European Union and the US took remedial actions to increase the resilience of the semiconductor sector by focusing on investments in R&D, design, and manufacturing. International cooperation will be increasingly critical for the US and for the EU to advance their semiconductor strategies. the Tech and Trade Council, which is since 2020 the diplomatic forum for the EU and the US to align on policies, will definitely play a very important role. And there is actually in this framework a specific working group focusing on secure supply chain. So industry hopes that this forum will really be central in the alignment between the EU and the US, and that semiconductors can really be the testbed for renewed transatlantic relations and stronger cooperation. We already mentioned some policy tools available for policymakers. What really governments can do? There are essentially three types of incentives. This list is non-exhaustive. I just want to give a flavor of what are some of the actions that governments can take. Governments can offer direct subsidies in the form of grants or investments fund. Governments can also put in place measures for tax reduction. This is the case of tax credit, tax incentives for R&D and talent acquisition. These measures are particularly important, particularly effective to make large investments financially sustainable in the long term. Also, the semiconductor sector would benefit from a more favorable regulatory environment that fosters a digital talent pipeline that promotes international cooperation. As I said throughout my presentation, international cooperation is key to also define requirements for the semiconductor sector, to align on practices, to align on ways to share information on future shortages, on how to address priority orders, how to address also certificate requirements like certifications that are popping up in different jurisdictions. Studies conducted by BCG and Kearney and other experts really show the cost disadvantage of building a new leading edge manufacturing facility in the US or in Europe compared to other competitive locations like South Korea, Taiwan, or China. The total cost of ownership can be on average 30 to 40% higher in the US or in Europe compared to other locations in Asia. Therefore, incentives, government incentives used to offset capital and operational expenses are becoming a key differentiator to attract investments in the different countries. When taking decisions on incentives and public funding, governments should consider the spillover effects, the positive impact of large leading edge manufacturing facilities for industry and for the broader ecosystem. According to a study carried out by Kearney, in a 10-year time horizon, a new mega fab with an investment, capital investment of about 18 billion euros would actually bring in 10 years 11 to 14 billion euros in labor income between direct, indirect, and induced labor income. Would also lead to a GDP expansion in the order of 85 billion euros, would also bring tax revenues to countries in the order of 11 billion, which would actually repay in the span of 10 years the gap of the cost of the total cost ownership with Taiwan, and would also lead to an enormous amount of new jobs, actually about 20,000 new jobs between direct induced and indirect employment. There are also other benefits that actually Intel experienced in its sites around the world: Arizona, Oregon, Israel, Ireland. New fabs, new facilities bring more innovation. They make the supply chain more resilient, more secure. They create a positive cycle of innovation because new startups, new scale-ups pop up in the proximity of the fab because they can use leading edge technologies. This increase in R&D also stimulate R&D and collaborations with universities and research centers. And last but not least, more fabs in Europe or in the US will actually create more talent and will help creating the next generation of engineers that will be able to design and produce the next generation of semiconductors. To conclude, I think today we saw that a confluence of trends and unexpected events for the semiconductor sector led to the current chip crunch. It is apparent that there's a need to address these vulnerabilities and rebalance the supply chain. Semiconductors are recognized as a top industrial priority by policymakers worldwide. Governments acted to boost innovation, increase supply chain, and respond to future crises, but more work needs to be done. It is clear that the role of public policy and public funding have become more and more important to ensure that the semiconductor sector can continue driving innovation and economic growth. Semiconductors power innovative technologies that allow society to address key challenges like climate change, healthcare, mobility, and many more to improve people's lives. So therefore, I think semiconductors can really be seen as enablers of prosperity and ultimately human advancements. So thanks everyone for your attention. I look forward to your questions.
Great. Thank you, Riccardo. That was fantastic. And I think you did an incredible job of laying out both the problem that needs to be solved and the potential for governments to be able to solve it and the key things that they could do to get that done. We've got one question in the chat already, and then I have a couple questions for you. Alexis asks, comparing the US and the EU CHIPS Acts, is there anything the US should learn from the EU CHIPS Act and try to implement?
I can just, yeah, I think you already did a fantastic job. You just said that the US one hadn't been fully implemented yet because of the budgeting issues, whereas the EU one, I noticed that they relied a lot, I think you said on public donations and private donations, which maybe I don't know the US system as well, but I don't really think that's something we do. So is there, not necessarily budget wise, but is there something else that the EU is doing that that we should try to learn from?
Sure. Shall I answer to this one, David?
Yeah,
First?
Yeah, go ahead.
Okay. Okay, well, indeed, the roadblock now is given by the fact that there has been a slowdown in the lawmaking process in the US, so that this very substantial envelope of money, $52 billion that should be used for R&D and manufacturing and design are pending approval. So actually what Europe has done well with its EU CHIPS Act is that they proposed a package of measures, and one of these measures, there's a communication that already outlines the principles for new investments, and so those investments can already guide. They can be seen as guiding principles for companies. Europe has done a good job in emphasizing and highlighting the need for faster permits and authorizations for new innovative facilities, because they have acknowledged that these facilities will be of public interest, and therefore and therefore need a fast track procedure. Overall, I have to say there's a strong alignment in the goals and hopefully also in the implementation of the two strategies of the two plans. So I'm confident that both the US and the EU will really make the most out of the US CHIPS Act and the EU CHIPS Act. And hopefully this will also lead to increased international collaboration. And we saw that the global supply chain, as much as the digital infrastructure, are by nature global, and so they really are at their best when countries can leverage collaborations across different regions and countries.
Great, thanks. And thanks, Alexis. Professor Rogerson has a question.
Hey, Riccardo, thanks very much for today. I'm on my phone, so I don't know if you can see me or not. I'm here. Yeah, there I am. All right. Nice to meet you. Thanks so much for coming today. One of the questions that has come up a ton recently is the impact of the natural resources on the supply chain. And I was wondering if you know anything or have any thoughts about how that's either improving or degrading at all, and where companies are getting their natural resources. Has that changed over time? Are they scrambling in a way that is like really depleting things? I don't know enough about the actual, geology of that out there to speak to it. And but just I'm really curious about the front end of getting to the companies and the factories, and if that has an impact in any way. Thanks again.
Thanks, Professor Rogerson. It is indeed a critical question, and as every hard question, there are no easy answers. What I know is that industry is also looking at this aspect, because it is true that right now we need to assess all supply chains and assess the resilience of all types of supply chains. Raw materials and in general natural resources are really important to semiconductor production. What industry is pushing for in this phase when we are defining strategies is getting more involved and be able to participate in defining also the next steps in order to be able to foresee and be able to anticipate some of the potential bottlenecks. And so finding ways for increasing the level of information across the different regions is probably one of the key objectives going forward to be able to address some of the problems that you just mentioned. Thanks.
Thanks, Ken. Asa.
Hi, Riccardo. Thanks so much for the presentation. Fascinating and really great to have you here. So you mentioned state incentives as a policy tool, and I'm curious if kind of giving state incentives to these national champion companies like the US, giving money to Intel, Taiwan giving money to TMC, how does that not fall afoul of free trade rules? And I guess the follow-up question is that if this is kind of the inexorable path that we go on, where states kind of fund these national champions, does that mean that there's really no chance that kind of developing countries are able to ever create their own champions that can compete with Intel? Because it's hard to imagine them doing so if like Intel, like $100 billion company, is receiving support from the United States.
Yeah. Excellent question, Asa. I'm not sure I have a comprehensive answer here. Definitely state aid, especially if we look at the rules in Europe, for instance, there are very strict provisions when it comes to state aid, because they should not actually create disruption in the market, and so should not favor too much one player compared to all the others. This is this is definitely an aspect that needs to remain important for policymakers. Now, the reason for government incentives and state aid is linked to, in some cases, the cost disadvantage that and the cost structure and the specific economics of semiconductors. So in some cases, some public funding is needed to be able to offset the cost disadvantage and to be able to actually have a more differentiate, more diverse supply chain and not counting just on few countries and few companies around the world. Now, when it comes to semiconductors, and you saw the slides when I was showing the different players, it is important to make sure that investments around the world can actually feed the R&D, can help improving research that would potentially lead to new champions around the world. But these are processes that require decades. And the reasons why there are now few companies that have the expertise and the technology to go to the next generation chips is because they have developed these capabilities in decades. So also the opportunity to broaden the number of countries that will be able to develop chips is definitely important, but will take decades. And so in the meantime, we need also to offer a buffer to supply chain shortages that really matter to all countries and not just to the countries which are producing semiconductors.
And I just would want to add on to something that Riccardo said. Asa, I think it's a fantastic question. I think when you're looking at $10 to $15 billion for a leading edge fab, the likelihood of new players developing and starting that kind of investment without state aid, there's a flip side to your question that could be asked, what's the likelihood of that happening? But then I think the second piece is to look at the piece that Mr. Masucci was referring to is the investment in the overall ecosystem and what happens once you have a partnership that's developed over time between a particular country and some of these manufacturers, that it develops an ecosystem where there's a lot of other entrants that come into play, additional roles in the development of other hardware and other software on top of that. So it ends up being a more complicated analysis of what's better for creating new entrants in what pieces of the overall semiconductor market. But it's a great question, and I don't think, given we know how that plays out, particularly because of the barriers that are created from the high cost of entry when it costs $10 to $15 billion. Justin, you had an additional question.
I did. I can forego if we're running too close to time here.
Go ahead.
I was just curious if you can speak to what, if anything, so far has come out of the US-EU TTC with respect to semiconductors, and then where that's headed.
Yeah, thank you. Thank you for the question, Justin. We are expecting a new meeting of the TTC in May, around mid-May. They in the previous meeting in Pittsburgh, semiconductor was part of the discussions, but there have not been deep discussions on semiconductor policies so far. And as I said, I truly hope that this will happen in the coming months. I think that the current international situation with the war in Ukraine may deprioritize some discussions like semiconductors, but definitely as industry we will continue push for a more open dialogue on these topics because it is crystal clear that there's a need to act now. And so governments need to take timely actions right now, and they cannot wait.
Riccardo, I've got two quick questions for you. I think short answers. The first is, I was wondering if you could just talk briefly about what the work is that you do in public policy to try to educate stakeholders on this problem and guide them towards solutions that are going to be productive.
Yep. Thanks, David. Actually, education is really the key activity in this in the advocacy action of industry in this phase, because semiconductors are now acknowledged as a critical element of the digital infrastructure, but there is still little knowledge among policymakers and probably more broadly also within industry and academia, or about the smallest details and the insights of this sector. So that is actually a priority to actually show which is the state of art of technology, which are the tremendous opportunities that semiconductors enable. And also, I think that in this exercise, this is an exercise that cannot be conducted in silos. So companies need to work with upstream suppliers and downstream customers to show to policymakers the enormous benefits coming from semiconductors. And this is also a type of conversation that cannot happen in single countries, but needs to happen internationally, because the challenges that countries around the world are facing are similar. Hence, again, this interaction with policymakers needs to be as much as possible inclusive of different industrial sectors, of different countries, in order to really be able to find the right solutions to address the current vulnerabilities.
Great, thanks. And that's a perfect lead into my last question then. Riccardo, you're doing technology policy now at the highest level, talking to governments all around the world, basically about how to partner with industry to invent the future and transform the lives of citizens in the way that it happens when top leading technology semiconductor products are deployed in technologies. We've got here at Duke, a interdisciplinary group of engineers, computer scientists, law students, and public policy students working together and investing their time to prepare to play a role in that future and to influence technology policy. What advice do you have for those students on how to prepare themselves to get to the place where you are and to have the kind of influence that you are making on the world?
Sure. Well, working on tech policy definitely requires a good understanding of technology, of its benefits and potential shortcomings. It also requires mastering decision making, so deeply understanding the lawmaking process of different countries, but also approaching international organizations and international fora that will be increasingly critical in addressing challenges that are not just about one single country, but that will definitely need a joint effort by multiple countries. So a truly multilateral approach. And the third piece of advice probably is, since I hear that there are students from different faculties, it's probably important to have a broader expertise, since technology is going to positively impact healthcare, mobility, and will probably try to give answers to the most pressing problems of today's world: climate change, cancer treatment, things of this nature. So it's really important to have the right expertise, a broader expertise, in order to be able to understand the solutions that digital can drive to the benefit of the society.
Riccardo, that's a fantastic place, I think, for us to stop. I want to thank you for being willing to come here and to deliver the talk, and also to take on the academic appointment that you have here at the Duke Sanford School. I know I and many of the students are really looking forward to working with you on these issues. So thank you again so much for your time.
Thanks a lot to you for the opportunity, and to all students and faculty for the attention and the fantastic questions. Thank you again.
Great. Thanks, everybody, and have a great week.
Likewise. Thank you.